Hello and welcome ProIT. And so I hope you guys are enjoying these sessions, right? I would actually ask you to go ahead and click on subscribe icon and then click on bell icon to get real-time updates of the videos as and when I'm going to going to upload them. All right. And also, if you're liking these videos, then please click on the thumbs icon. That actually helps in giving me motivation to come up with the new contents as soon as possible. Okay, so great. And if you have any further queries, you can post them in the comment section. All right, great. Let's go right into the session. So till now, what we have covered is the various options that Azure provides on the compute sections, right? The last thing which we want to cover, that is about Azure serverless functions, right? So serverless, what are the things that we can do and why we should be going with the serverless? What are the things that are part of the serverless? Those are the things that we are going to cover in this session. All right, great. I'll see you in the session then. Thank you. Welcome back, ProITians. So in this session, we are going to look at serverless computing, right? Let's get started. So what is serverless computing? Serverless computing is the abstraction of servers, infrastructure, and OSs. With serverless computing, you don't have to worry about the underlying infrastructure. Azure takes care of managing the server infrastructure, right? And also allocation and deallocation of resources are based on the configuration you have set. With serverless computing, you can build applications faster as infrastructure is managed by Azure. Scaling and performance are handled automatically and you are built only for the exact resources you use. There is no need to even reserve a capacity. Codes are being run on the servers at the backend, right? So let's have a look at the architecture of serverless computing. Okay, so there are three components of the serverless computing, right? The first one is the abstraction of servers. Serverless computing abstracts the servers you run on. You never explicitly reserve server instances. The platform manages that for you, right? So each function execution that can run on a different compute instance, and this execution is transparent to the code. With serverless computing, you simply deploy your code, right? The next one is event-driven scale. So serverless computing is an excellent fit for the workloads that respond to incoming events, and events could trigger by timers. For example, if a function needs to run every day at a particular time, like for example 9 p.m., then it can actually hit it by that timer, or via HTTP, for example API and webhook scenarios, or via queues, for example with order processing, and much more. Next one is micro billing. So traditional computing has the notion of per second billing, right? But often that's not as useful as it seems. Even if the customer's websites get only one hit a day, they will have to pay for the entire day's worth of availability, right? So with serverless computing, you only pay for whatever amount of time the code is running. If no activity is functioned, then they will be not charged, right? For example, if a code runs once in a day for 2 minutes, they charge only for the execution of 2 minutes of computing time, right? Great. Let's move to the next concept. So Azure Serverless Computing implementation. So there are two components of Azure Serverless Computing, that is Azure Functions that can execute code in almost any modern language, and then there is another one, that is AzureLogicApps, which are designed in web-based designer and can execute logic triggered by Azure service without writing any code. Alright, let's talk about Azure Functions. Yeah, because those are the two components of Azure Serverless Computing, right? So Azure Functions, they're commonly used when you need to perform work in response to an event, like how we saw about the timer and all, often via a REST API request, timer, or messages from both Azure service, and when that work can be completed quickly within seconds or less, right? Azure Functions can scale automatically based on demand, so there is solid choice when demand is variable. For example, you may be receiving messages from IoT solution used to monitor a fleet of delivery devices, right? You will only likely have more data arriving during business hours, right? So that's when you're going to use that, right? It will scale automatically based on the demand. Okay. Azure runs the code when it is triggered and automatically deallocates resources when the function is finished. In this model, you only charge for the CPU time used while your function runs. Furthermore, Azure Functions can be either stateless, where they behave as it's restarted every time they respond to an event, or stateful, where a context is passed through the function to track prior activity. Functions are a key component of serverless computing, but they are also a general compute platform for running any type of code. If this needs of the developer app change, then you can deploy the product in the environment that isn't serverless, which provides the flexibility to manage scaling, run on virtual networks, and even completely isolate the application. Right? Let's move to the next concept, that is AzureLogicApps. So AzureLogicApps are similar to functions, but enable you to trigger logic based on an event. When function execute code, logic apps execute workflow designed to automate business scenario and build from predefined logic blocks. Logic apps execute workflow designed to automate business scenario and built from predefined logic blocks. Every logic app workflow starts with a trigger which fires with a specific event happens and when newly available data meets specific criteria. Many triggers include basic scheduling capabilities, so developers can specify how regularly their workload will run. Each time the trigger fires, the logic apps engine creates a logic app instance that runs the actions in the workflow. These actions can also include data conversations and flow controls such as conditional statement, switch statements, loops, and branching. So you create logic app workflows using a visual designer or the Azure portal or in Visual Studio. Yeah. So the workflows are processed as a JSON file with a known workflow schema. All right. So let's look at the comparison of functions and logic apps. So here's the table of the comparisons. So broadly speaking, functions and logic apps can both create complex orchestrations. An orchestration is a collection of functions or steps that are executed to accomplish a complex task. With Azure Functions, you write code to complete each step. With logic apps, you use a GUI to define the actions and how to relate to one another. Right? This is the comparison for functions and logic app. Alright, so for further information, further learning on Azure, you can refer to these articles. Okay, and That's all for now. Please do subscribe for the channel and hit on the bell icon to get real-time updates on as soon as the videos are getting uploaded. Also, please click on the like icon if you're liking the videos, and feel free to share the videos to your friends and colleagues. Right? Until next time, keep watching and keep learning. Thank you.